if I have to draw a diagram, okay, then it's a kind of a unlimited space, okay, rho s, okay, and there is a 2 sin phi करके वो charge density है वहाँ पे, and there exists at r is equal to 1 there exists a circular disk. So r is equal to 1 is a circular area. It's a circular area, okay, whose radius is going to be same. So therefore, this is an infinite plane, okay, and out in that infinite plane there is this disk whose radius is 1 meter. Okay, so how much flux will be emitted by this circular area? So as per Gauss law, the charge which is enclosed by this circular area is nothing but flux. So if you calculate the charge which is enclosed by this circular disk, okay, then that is nothing but flux. Okay, so you know how to calculate charge, to calculate basically charge when rho s is given to you. Okay, so you know the formula that charge is equal to integration rho s ds. Okay, this is a formula to calculate charge if you have given rho s. If you are given, obviously it is going to be double integration because it is a surface area, and if you are given rho v, then triple integration rho v dv will be the another formula, and if you are given rho l, then single integration rho l dl will be the third formula to calculate the charge, and this charge is nothing but equal to flux as per the Gauss law. Okay, so we will calculate the charge and then we will say at the end that this charge is equal to flux emitted by the Gauss law. Okay, so rho s ds, rho s क्या दिया है 2 sin phi. Okay, now what is ds? Okay, now sin phi दिया है मतलब ये आपको सिलेंड्रिकल में दिया हुआ है. सब तो कल हम लोग ट्यूटोरियल में देख रहे थे कि कौन सा फॉर्मूला डिपेंड, कौन सा फॉर्मूला यूज करना है, दैट डिपेंड्स ऑन व्हाट इज द डेटा व्हिच इज गिवन टू यू and in which coordinate system the data is given to you. So if the coordinate system is rectangular, then you use the formula for rectangular. If it is a circular, then you use the formula for circular. So now we will write down the expression for ds for r is equal to one surface. So you know for r is equal to one surface, I am going to multiply r d phi and dz. Okay, so that becomes my ds. Okay, so this into r d phi dz. Okay, so this is equal to 2 constant integration. R is also constant whose value is 1. Okay, so r is 1 for this surface. So wherever there is r in the formula, you just substitute 1. Integration sin phi d phi integration dz. तो phi और dz, ओके, इसका लिमिट्स डालना है. अभी मैंने आपको बोला था जब भी फर्स्ट लेक्चर हुआ था तभी phi का लिमिट जो होता है ना, phi का लिमिट जो होता है 0 to 2 pi होता है. Unless and until it is given to you, you take the limits of phi as 0 to 2 pi. So it is 0 to 2 pi and dz. Okay, so dz का आपको लिमिट okay, I'm so sorry. Okay, so see, the radius of this particular surface is 1, but the location of this surface is at z is equal to 0. Okay, so radius is 1, but the location of this surface is z is equal to 0. So therefore, when you calculate ds, then it has to be r d phi into dr. Okay, r d phi into dr. Okay, so therefore this has to be
वो कैसे
dr.
होगा?
हाँ, मतलब कैसा है, r is the maximum limit. देखो जैसे कैसे होगा कि ये तुम्हारा सरफेस है ना, सो यू कैन इमेजिन स्मॉल स्मॉल सरफेसेस हियर. सो हर एक सरफेस का रेडियस अलग होगा ना, हर एक सरफेस का रेडियस अलग होगा. सो लिमिट इज 0 to 1. लिमिट इज गिवन एज 0 to 1 फॉर द रेडियस. सो जो मैंने डायग्राम ड्रॉ किया है दैट इज अ लिमिट. ओके, दैट इज 0 to 1 इज अ लिमिट, इसलिए वो ये ऐसा मैंने डायग्राम ड्रॉ किया है. सो इसलिए, बट ये सरफेस किधर है? इट इज ऑन द फ्लोर. द फ्लोर इज z is equal to 0. So you take any point on this surface will have z value 0. लेकिन any point will have radius different. इसका रेडियस अलग होगा, इस पॉइंट का रेडियस अलग होगा, इस पॉइंट का रेडियस अलग होगा. सो रेडियस विल बी डिफरेंट. व्हाट इज गिवन टू यू एज इज r का लिमिट दिया है 0 to 1. So if you consider a surface which is at the origin or nearer to origin, so the radius could be 0. Okay, so therefore ds कैसे लिखता है? r d phi into dr. Okay, so यहाँ पे आएगा dr. Okay, यहाँ पे आएगा dr और उसका लिमिट रहेगा 0 to 1. Okay, so this disk is perpendicular to z axis. This is z axis. Okay, so it is disk है ना, it is perpendicular to z axis. So it is nothing but at the floor it is z is equal to 0. Okay, so the location of this disk is z is equal to 0. As all the, if you take any different points here, the radius could be different, but the z coordinate of all these points will be same. So at these different points, you can consider a small surfaces through which the flux is going to pass. Okay, so what we are doing is we are calculating the all those small flux which are being emitted by these small areas, and then by integration we are basically adding all those fluxes. Okay, so therefore यहाँ पे r is equal to 1 आएगा. Okay, sin phi d phi into dr 0 to 1. So if you calculate this answer, you know it is going to be 0 because sin phi का integration will be cos phi. Okay, limit will be 0 to 2 pi. और इसका आएगा r, लिमिट विल बी 0 to 1. सो cos phi 0 to 2 pi अगर आप सब्स्टिट्यूट करते हो तो ये आंसर 0 आता है. सो 2 into 0 multiply by 1 will be 0. Okay, so इसका मतलब है that the flux which is emitted is 0. The reason being इसका मतलब है कि जितना फ्लक्स अंदर आ रहा है उतना ही फ्लक्स बाहर जा रहा है. जितना फ्लक्स यहाँ से अंदर आ रहा है उतना ही फ्लक्स बाहर जा रहा है. सो टोटल फ्लक्स which is enclosed by the charge which is enclosed by that particular disk is going to be 0, and therefore the flux emitted by that particular disk or the surface is going to be 0. So whenever you get 0 flux, indicates that there are equal and opposite charges, okay, which are enclosed. That gives you a 0 charges which are enclosed by the surface. Okay, so this was the first problem.
Ma'am, are there any conditions where flux will not be 0? Sorry, charge will not be 0.
Yes, अगर ये sin phi नहीं है तो देखो sin phi कैसा होता है, ऐसा होता है ना. सो यहाँ पे फ्लक्स अगर इनवर्ड है तो यहाँ पे आउटवर्ड है. सो sin phi अगर नहीं है, एनी अदर कॉन्फ़िगरेशंस, ओके, तो चार्ज का कॉन्फ़िगरेशन कैसा है? देयर इज अ sin phi. ओके, सो इसका अगर आप इंटरप्रेट करोगे विथ रिस्पेक्ट टू चार्ज, देन sin phi का टोटल वैल्यू कितना होता है? 0 होता है ना ओवर वन साइकिल, बिकॉज यू हैव इक्वल एंड अपोजिट वैल्यूज.
Yes, ma'am.
ओके, सो इसका मतलब अगर आप विथ रिस्पेक्ट टू चार्ज अज्यूम करते हो तो इसका मतलब है देयर आर इक्वल एंड अपोजिट. यहाँ पे अगर प्लस क्यू चार्ज है तो यहाँ पे माइनस क्यू चार्ज है. सो ये चार्ज डिस्ट्रीब्यूशन ऐसा है कि जहाँ वहां पे इक्वल एंड अपोजिट चार्जेस है. दैट इज द रीजन दैट द टोटल चार्ज विच इज एनक्लोज्ड बाय दैट डिस्क इज 0. सो अगर रोएस का आपका जो टर्म है, रोएस जो दिया हुआ है, उसमें अगर ये sin phi नहीं है तो आपका कुछ आंसर यहाँ पे आएगा. Because of this sin phi, you are getting this answer 0.
सारे इंटीग्रेट होगा ना?
हाँ,
मिस अगर साइन मिस आर रेडियस इंटीग्रेट होगा ना अगर dr है तो?
हाँ मैम, वही, क्योंकि आर और डी आर के टर्म में कर रहे ना,
हाँ।
तो आर तो वेरिएबल होगा यहाँ पे.
नहीं, वैसा नहीं है. R वेरिएबल क्यों होगा? सी, जैसे मैंने आपको ओके, सो आई जस्ट ये
अर्चना मैम,
हाँ सर, मैंने शायद पीपीटी में ये नहीं बनाया ना, तो इसलिए वो प्रॉब्लम है. हाँ सर बोलिए।
हाँ नहीं, वो क्या शेयर कर रहे कीजिए, फिर देन आई विल स्पीक इफ इट इज रिक्वायर्ड. Students, what you are saying, na, dr is there, it means it's a variable. Of course, that's true.
हाँ सर, आप एक्सप्लेन करो सर.
I need diagram.
Okay, so 1 minute. I'll just draw the diagram. 1 minute. एक्चुअली वो पीपीटी में ना सर एक ही पीपीटी बनाया था, तो मैं स्क्रॉल अप डाउन नहीं कर सकती थी, इसलिए मैंने वो 3-4 पीपीटी बनाए.
Okay.
So I'll just draw the diagram. So this is your OS, and this is that disk of radius r. ये रेडियस है r. तो आपको कैलकुलेट करना है चार्ज एनक्लोज बाय दिस क्लोज सरफेस. हाँ सर.
Disk है तो then the surface will be open. Or okay, the outer surface is closed surface.
Sir, what I
That
feel
random surface is there, na, that is closed surface, which is enclosing a disk, right?
yes, this one.
हाँ, okay, ठीक
So
है.
here there are
So-
charges.
So there
Here
must
there are charges.
not on the disk.
Not on the disk. Disk is enclosing. पूरा ये जो surface है ना, यहाँ पे वो charges है. This is rho s. And
Surface
there
charge.
are some charges which are enclosed by this disk.
मिस वो फ्लक्स है ना.
फ्लक्स मतलब क्या है? ऐसा जो ऐसा तो
Flux is just the impression. Flux is just the impression created by the particle.
दिस इज योर फ्लक्स. ओके, लेकिन ये जो रोएस है ना, ये रोएस का डिस्ट्रीब्यूशन कैसा है? 2 sin phi है. ओके, सो इसका मतलब है ये जो तुम्हारा डिस्क है, ये जो तुम्हारा सरफेस है, यहाँ पे प्लस क्यू चार्जेस भी है, निगेटिव क्यू चार्जेस भी है. सो यहाँ पे क्या होगा? फ्लक्स विल बी एमिटेड और यहाँ पे फ्लक्स विल कम इन दिस वे. तो अगर ये दोनों एनक्लोज हो रहे हैं तो नेट फ्लक्स विल बी जीरो ना, नेट
course.
चार्ज विल बी जीरो ना. दैट
Yes,
इज व्हाट
please.
हैपनिंग हियर. इसीलिए फ्लक्स जीरो आ रहा है. तो यहाँ पे अगर प्लस क्यू चार्ज 2 है तो माइनस क्यू चार्ज भी 2 है. तो हाउ मच चार्ज इट इज एनक्लोजिंग? 0. तो चार्ज एनक्लोज 0 हो गया तो फ्लक्स 0 हो गया. तो ये जो साइन फाई, ये जो रोएस का डिस्ट्रीब्यूशन दिया है ना, बिकॉज ऑफ दैट योर आंसर इज कमिंग 0. ये जो इसका रोएस का डिस्ट्रीब्यूशन है ना 2 sin phi, because of that your flux is coming as 0 coulomb. So अगर ये sin phi के जगह 2x स्क्वायर है या फिर 2y डिवाइडेड बाय 2 कुछ भी दिया है, ओके, या फिर 2r दिया है सपोज, या फिर 2z दिया है, then your answer will be there. ओके, सो आपने अभी फॉर्मूला क्या लगाया था? इंटीग्रेशन रो एस ds ना. So it was rho s was 2 sin theta, ds was r sin phi dr. Okay, so ये जो sin phi है ना, उसके वजह से प्रॉब्लम हो रहा है, बाकी कुछ नहीं. Is that fine? Or you still have doubts?
मिस इसमें जो रेडियस है, मिस हम लोग ने जो रेडियस डिफाइन किया, मिस वो भी इंटीग्रेट होगा ना अभी.
हाँ, तो रेडियस इंटीग्रेट होने देना. तो इसलिए वो इनटू 0 to 2 pi.
मिस ने पहले इसमें कांस्टेंट लिया था ना रेडियस को बाहर, इसलिए पूछा. इस बार इंटीग्रेट हो जाएगा ना वो.
हाँ, रेडियस इंटीग्रेट हो रहा है. 0 to 1 है ना, 0 to 1 dr है ना, लेकिन ये इसका जो आंसर 0 आ रहा है ना, so it is going to be 2 multiplied by 0 multiplied by 1, इसीलिए 0 आ रहा है. सो रेडियस जैसे अभी ये तुम्हारा डिस्क है ना, ये डिस्क है. दिस डिस्क इज मेड अप ऑफ स्मॉल स्मॉल सरफेसेस. तो हर एक सरफेस का रेडियस अलग होगा ना. जो सरफेस यहाँ पे है उसका रेडियस 1 है. सो व्हाट इज गिवन इज दैट यू आर गिवन द लिमिट ऑफ r as 0 to 1. बट ये डिस्क लोकेशन कहाँ पे है? कांस्टेंट क्या होगा इसमें, यू टेक एनी सरफेसेस, उसका z कोऑर्डिनेट हमेशा 0 रहेगा. phi will change, r will change, but z will be always 0. So ds जब भी हम लोग लिखते हैं ना, तभी आपको देखना है कि कौन सा कोऑर्डिनेट 0 होता है. तो अगर यहाँ पे 0 z है, तो we are going to multiply it with r d phi and dr only. That means d phi is changing and dr and phi both are changing. So r का लिमिट है 0 to 1 और phi का लिमिट है 0 to 2 pi. And since here it is changing with respect to phi and you have sin phi here, your answer coming is 0. Is it
miss.
okay?
Yes, miss.
See, simply what is happening there, whatever disk is there now, the charge distribution is function of angle. So it's a sine function. Okay, so 0 to your 180-degree sine function is positive, and for the next half cycle, it is what, negative. It means that for half of the disk there is positive charge, and for half of the disk there is negative charge is there. And because of that, what is happening, that the net charge, it becomes 0. That is the meaning of this equation, rho s equals to 2 times of sine phi. Sine phi is there means the nature of charge is changing as per the angle.
Yes, sir.
Okay. Okay. Next problem लिखो. Okay. A uniform line charge with rho L is equal to 3 microcoulomb per meter. A uniform line charge with rho L is equal to 3 microcoulomb per meter lies along x-axis. So on the x-axis there are charges. Okay. What flux is crossing a spherical surface centered at the origin? What flux crosses a spherical surface centered at origin with r is equal to 3? A uniform line charge with rho L is equal to 3 microcoulomb per meter lies along x-axis. What flux crosses a spherical surface centered at origin with r is equal to 3? इसका मतलब है ये जो x-axis है, यहाँ पे charges है. There are charges on the x-axis with density 3 microcoulomb per meter. Okay, and there is a sphere which is centered at origin. That means origin पे उसका center है. This is the sphere. और उसका रेडियस कितना है? उसका रेडियस है 3 meters. So how much flux will be emitted by this sphere? Okay, so flux is equal to charge enclosed.
Ma'am, that disk is placed along that xz plane, isn't?
No. ऐसा नहीं दिया है. ऐसा कुछ दिया नहीं. What they have at the you can consider that. अगर आप ऐसा अगर अभी मैं मुझे आपको सिखाना है इसलिए, otherwise you can consider this as the x-axis. अगर आप आपका जो स्फीयर है, अगर आप z is equal to 0 में assume करते हो, okay, then this is your x-axis and this is the sphere. So your sphere is basically enclosing some part of the x-axis. Am I clear?
Okay.
Okay, so अगर आप वो स्फीयर को हॉरिजॉन्टल रख रहे हो, then this is your x-axis. Okay, then this is y and this is z if it is horizontal. So basically this sphere is enclosing this much part of the entire infinite x-axis, and that length is nothing but 3 meters, which is the radius of a sphere. And this is also going to be enclosed, right? Because x-axis is it's from minus infinity.
Ma'am,
to,
it's a length charge density, right?
yes.
Okay, then fine.
Okay. So how much length is going to be enclosed? How much length is going to be enclosed by this sphere is going to be 3 meters plus 3 meters, that is 6 meters. So total length which is enclosed by the sphere is 6 meters, as your x-axis is extending from minus infinity to plus infinity. Okay. So therefore, if you want to calculate charge, flux अगर calculate करना है, basically you want to calculate charge enclosed. So how much charge will be enclosed by that is going to be rho L into the length. Okay, so ROL कितना दिया है 3 micro multiply by length is how much 6 meters. Okay, so ROL is 6 micro, so answer will be 3 micro coulomb. So flux or charge which is enclosed is going to have the same unit. So therefore flux emitted by this sphere is going to be 18 micro coulomb. Okay, so basically यहाँ पे important क्या है कि चार्ज कितना enclose हो रहा है by that surface, वो अगर आप calculate करोगे then that is nothing but your answer. Is it clear to everyone? So you can expect such type of small problems in the exam. Okay, maybe for 2 or 3 marks. Okay, is it clear?
Ma'am, if we increase the radius, then accordingly charge will also increase, right?
Yes. तो
Okay.
इसका मतलब इतना इतना जो ये जो लेंथ है ना, ये जो लेंथ है, इतने लेंथ में आपका चार्ज है.
Yes, ma'am. For the length only.
So ये चार्ज जितना भी एमिट करेगा, that much flux is going to be emitted or pass through that particular sphere. Okay, तो ये flux calculate करना difficult है ना. So using Gauss law, you can calculate flux by calculating charge enclosed. Okay. So now we will again go to the
Excuse me, ma'am.
yes. Harun.
Yesterday you said that structures like sphere and all comes into the section of volume. So there we do the integration and all. So when that comes into the picture, those integrations.
हाँ, लेकिन यहाँ पे आपको इंटीग्रेशन रोयल दिया हुआ है, तो इट्स गोइंग टू बी सिंगल इंटीग्रेशन बिकॉज चार्जेस आर नॉट ऑन द स्फीयर, चार्जेस आर ऑन द लाइन.
Okay, so it's dependent of charges.
It depends on where the charges
ma'am,
are
got it.
distributed.
What you do now that whenever you are confused whether to go for the surface line or volume integration, you just check the unit of the charge distribution. If it is per meter, then it means along the line. If it is per meter square, means you have to go for surface integration, that is double integration. If it is per cubic meter, then it's volume.
Yes, ma'am did mention that. Yes.
Huh. Huh.
So now we will go to the okay, now we will see the next concept. The next concept is a point form of Gauss law. Point form of Gauss law. Okay, so we were talking about the point form of Gauss law. We show the expression for point form, and I'll just explain to you why we are going for point form. Okay, so the reason we are showing you this because this is one of the Maxwell's equation. Okay, so this particular expression is called as a point form of Gauss law. It is also called as a differential form. Okay, so why we are going from when we already know Gauss law? Why we are going for a point form? So students, yesterday I was talking to you that whenever you study any subject, okay, first to understand the concept, you understand the theoretical background, and you start with the hypothetical term, and then you apply that particular concept to the practical real application or the real practical aspect of it. So whenever you apply a Gauss law and you calculate an electric field at any point, then because see, if you're using the formula which you have already studied using Coulomb's law, and if you want to calculate electric field, then what you should know is the coordinate of that point where you want to calculate the electric field, which is very much impractical or which is very much theoretical to know the coordinates of any point. So therefore, to solve this problem, suppose I don't know the coordinates of that point where I'm interested is in measuring the electric field, then how do you go? How do you proceed about it? So for that, you go for a Gauss law. So using Gauss law, you can calculate electric field at any point, even though you do not know the coordinates of that point. Okay, but what you need to consider is you have to consider a Gaussian surface which is passing through that point. Okay, because Gauss law is applicable to only closed surfaces. So therefore, one has to assume a Gaussian surface which is passing through that point in order to calculate the electric field at that point. Okay, but this phenomenon of electric field, okay, so basically you have to assume an imaginary closed surface in order to apply the Gauss law. Again, there is a limitation. Every time it is not possible, okay, for you to imagine a Gaussian surface and calculate the electric field, because all the phenomenon is basically happening at a point. Okay, so when I say that the electric field at a point, I'm interested in that. I'm interested that at that point what is happening. At that point, how much flux is passing. So ये जो आपने Gaussian surface जो आपने assume किया है, okay, which is enclosing that point, okay, that has to reduce to a point form. इतना reduce करना है उस Gaussian surface को that it reduces to a point. Okay, so if I have to apply a Gauss law to a point, I cannot apply Gauss law to a point. I have to apply a Gauss law on the closed surface. Okay, so if I want to apply Gauss law at a point, I have to reduce that particular closed surface so that it becomes a point. Okay, and then only I can apply a Gauss law practically. Okay, so in order to apply the Gauss law practically, we go for the point form of Gauss law, which says that divergence of d bar is equal to rho v. Okay, so that's what. So it helps us to find out how field behaves at a point. Okay, so this is one of the Maxwell's equations. So you need to remember it. Even in GATE exam, many times they tell you to identify the Maxwell's equations. So one should understand that there is a Maxwell's equation, and please remember there is a dot between del and d. Okay, so in GATE exam, what they do, they give you the same expression without a dot. Okay, and they tell you which is not a Maxwell's equation. Such type of questions are very much familiar in the GATE exam. So what happens is you don't pay attention to this dot. Okay, and therefore आपको लगता है कि अरे ये रॉन्ग क्वेश्चन है, बट रॉन्ग क्वेश्चन नहीं है, रॉन्ग आपका अंडरस्टैंडिंग है, बिकॉज ये जो डॉट क्रॉस ये जो साइंस होते हैं ना, normally we overlook it, we don't pay attention to it because there is a significance. So here we are taking a dot product of two vectors. This del indicates the rate of change of this vector. Okay, so therefore whenever you take the divergence of any two vectors, the answer is going to be a scalar, which is nothing but rho v here. So rho v is a scalar value. Okay, so whenever you write down any Maxwell's equations, you have to be very careful dot किधर है और cross किधर है. Okay, next is the divergence theorem. Okay, so divergence theorems basically relates the the close double integration to
मिस अपने स्लाइड चेंज किया है
हाँ अभी नहीं दिख
मिस
रहा.
विजिबल नहीं है डाइवर्जेंस थ्योरम का स्लाइड
अभी देखो यहाँ पे थोड़ा नेट अभी यहाँ पे थोड़ा सा अभी दिख रहा है.
नहीं नहीं मैम.
नहीं मिस
मैम 63 पे है.
अभी दिख रहा है.
हाँ, now it's visible.
So just remember this divergence theorem expressions. Okay, so divergence theorem हम लोग क्या करते हैं, इसी लेफ्ट हैंड साइड में हम लोग यहाँ पे डबल इंटीग्रेशन है और राइट हैंड साइड में यहाँ पे ट्रिपल इंटीग्रेशन है. Okay, so basically divergence theorem relates the double integration to triple integration. So if you just pay attention, this is nothing but our Gauss law. Okay, so on the left hand side there is a double integration d bar dot ds bar, which is nothing but flux. Okay, and on the right hand side we are saying it is equal to triple integration. What is this? अभी हमने देखा this is nothing but ये जो है this is your point form. And this is equal to rho v. This is rho v. So basically what you are calculating here is rho v dv, which is nothing but charge. Okay, so we are relating using a divergence theorem closed surface integral with a volume integral. So whenever you say a closed surface integral, so whenever you consider some closed surface, suppose a cube, there is some volume inside it. There is a volume which is trapped inside these closed surfaces. So therefore, using divergence theorem, one can relate the closed surface integral with a volume integral. So what we are basically calculating here is flux is equal to flux is equal to charge enclosed by the volume. Okay, so flux is equal to charge enclosed by the volume. This is very important expression. Again, we are not asking any problem on this particular expression. Just a theoretical concept should be understood by the students. Okay, and now we will take a break and we will again meet after it's 1:10. So we will meet again after 10 minutes and we will continue our chapter with the long-term and potential. We will take a break of 10 minutes. is June. So now we are basically understanding the concept that is the potential. Okay, so before understanding potential, one should understand what is work done because we are related. So mathematically, if you say work is defined as product of displacement D and parallel applied force. Okay, so unit the work is equal to F into D. The unit is going to be Newton meter as it is multiplication of force into displacement. Okay. So, what is force? What is work done is basically the energy which is spent. Okay, so energy is spent because if there is existing energy or if there is existing force in the vicinity and you are doing some activity, then you have to overcome this force, or that force will do the activity for you. Anything can happen. So, if so, either the energy will be spent by the existing force, or the energy energy has to be spent uh, by the entity who is doing that activity in order to overcome that force. Therefore, the work done is nothing but the energy which is spent. Let us consider it with respect to uh, our subject. Okay, so there is a, as you can see in this diagram, there is a force or there is an electric field which is shown by uh, this particular arrow. So there is an electric field in this direction. There is an electric field in this direction which is shown by E. Okay, and you are moving a charge in the vicinity or inside this electric field in the same direction. So in this case, what will happen when I say there is an electric field? That means there is a force which is existing. Okay, so in this existing force, if you are moving a charge from say A to D, A to B, or in a distance of with a distance of D, then that that force which is existing force. Okay, so this force will spend the energy to move this charge. Okay, this particular energy is spent by the force which has been existing. So therefore, we say that the work done is going to be F into D. Okay, and if electric field, as I said in the previous slide, it was the parallel force. So if the force is not parallel, it's inclined. Okay, then we have to take a cos component of it so that you bring it parallel to the displacement. So therefore, here it is written W is going to be or in this particular equation, the F is converted into in terms of electric field. So you know electric field is F upon Q. So therefore, F is Q into E. Okay, so it is, so here the F bar is written as Q into E bar. So if the charge is moved at an angle, so if the charge is not moved in the parallel to the force lines, if it is moved in this direction, then you have to take a cos component of that. If you have, suppose this angle is theta, then you have going to take the cos component of that so that you bring this displacement in the same direction of force. That is why it is written d cos theta. So now the work done is going to be Q into E d cos theta. Okay, so we have studied A dot B is going to be AB cos theta. So therefore, here the two vectors are E bar and D bar because D को भी कुछ direction है. So therefore, E into D cos theta is nothing but E dot D bar. So this dot is not for multiplication. This dot is for as a dot product. So I can say that the work done is going to be Q into E bar dot D bar. So work done का ये formula आ गया in terms of electric field. Okay, and what is theta? Theta is the angle between the two vectors E bar and D bar. Okay, so if this is so, then now I can write down the expression for work done in this way. Okay, so so displacement is in the same direction as that of electric field. We say that the work done is positive. And if the displacement is in the opposite direction as that of electric field, so if you move the charge from left to right and my force is in the same direction of in the same direction of the displacement, that is from left to right, then the work done is positive because the force is doing that. Energy spending is done by the force which is existing. Therefore, we say that there is a positive charge loss when it moves in the direction of electric field, and whenever the charge is moved against the electric field, okay, then we say that the positive charge gains the potential energy. Okay, so therefore, if you move the charge, okay, if you move the charge from A to B, then the same formula. So here you know how much is the distance. Okay, if you don't know the distance, if you know that the charge is moved from A to B, okay, then this is the formula. Okay, that is W is equal to minus Q. As you are moving against the electric field, it is minus Q integration A to B. So basically, you are moving a charge from A to B, and E bar dot dl bar. Okay, so in the earlier slide, you okay, omega. In this slide, you knew the distance d, but suppose you don't know the distance. So in terms of a differential length, the same expression is written. This is in terms of differential length. So A to B is basically calculating the total distance here. Okay, so this formula and that formula are not different. Okay, there the displacement D was known to me. Here I don't know how much it has been displayed by. So if I want to calculate the total length, okay, if I know the end points A to B, and if I don't know the total length, then I can calculate it by the integration. So this is
मिस डीएल कैसे फाइंड आउट करेंगे इसमें मिस क्योंकि डिस्प्लेसमेंट तो दिया नहीं है ना
that's what DL is a differential length. Okay, so you know in coordinate systems, differential length is dx dy dz in rectangular. Okay, and in cylindrical it is dr r d phi and dz. Okay,
Yes.
so accordingly we can take this in our formula. Okay, so when we will solve the problem, that time you will come to know how to take this DL. Okay.
Ma'am, length will be taken from that limit that from A to B, right? That for how long the charges are flowing
I didn't
from A
get. Can you
point to
please
B point.
repeat करना, मुझे सुनाई नहीं दे रहा है, मुझे बराबर समझ में नहीं आ रहा. Can you repeat?
Ma'am, can you hear me?
आवाज तुम्हारा बहुत ही प्रॉपर नहीं आ रहा है. फिर से एक बार.
ओके मैम, मैं ये बोल रहा था कि ए पॉइंट से बी पॉइंट तक जितना वो लेंथ के ड्यूरेशन में चार्ज होगा वही फाइंड करेंगे ना विद रिस्पेक्ट टू दैट डीएल.
there is a electric field और you are moving a charge from A to B. कौन सा charge? Q charge. Q
Yeah.
charge आप move कर रहे हो A to B. So whenever you are moving a charge from one place to another, inside the electric field, some energy has to be spent. That energy either the electric field will spend or it has to be supplied from externally, because there is already the train. अभी अगर तू विरार की ट्रेन में चढ़ गया, okay, चर्च गेट में, is it possible for you to get down at Borivali? No. Okay, और अगर विरार में तुझे उतरना है तो विरार में उतरने के लिए बहुत लोग होंगे, तो you have to just stand and you will automatically get down, right? लेकिन अगर विरार में सब लोग उतर रहे हैं और तुझे चढ़ना है, तो यू हैव टू स्पेंड द एनर्जी ना, एक्सटर्नली तुझे एनर्जी स्पेंड करना पड़ेगा इन ऑर्डर टू गेट इन. सिमिलरली ऑलरेडी अगर फोर्स है और उसी फोर्स में अगर तुझे चार्ज को मूव करना है, तो यू डोंट हैव टू स्पेंड द एनर्जी विल बी स्पेंड बाय द एग्जिस्टिंग फोर्स. लेकिन अगर आपको उल्टा उसको मूव करना है चार्ज को, okay, then
Yes, sir.
इसलिए वो जो हम लोग whenever we say that the किसी भी सर्किट में अगर आप whenever you apply any force or when you apply any potential to a circuit, closed circuit, okay, you are providing a electric field, okay, and that electric field, उस electric field में your charges are moving, that means the current flows. सो वर्क डन होता ही है वहां पे भी, इसलिए हम लोग रेजिस्टेंस के थ्रू पोटेंशियल ड्रॉप लिखते हैं ना, पॉजिटिव टू निगेटिव। am I clear? ये जो हम लोग पढ़ रहे हैं कुछ अलग नहीं है। दिस इज व्हाट हैपेंस इन द नॉर्मल इलेक्ट्रिक इन द नॉर्मल सर्किट लेवल में भी वही होता है। यहाँ पे हम लोग वेव की बात कर रहे हैं, लेकिन व्हाट वी आर टॉकिंग अबाउट इन द सर्किट लेवल, एनटी में भी अभी आप सर्किट क्लोज सर्किट में केवीएल अप्लाई करते हो, आप क्या करते हो, केवीएल में वोल्टेजेस ऐड करते हो ना, एंड देन यू से इट इज जीरो, राइट? So whenever you say there is a potential drop or potential gain, that is what is written here. Positive charge losses potential energy. Okay? अगर आप उसी डायरेक्शन में चार्ज को मूव कर रहे हो, इसलिए रेजिस्टेंस में देयर इज अ पोटेंशियल ड्रॉप, पॉजिटिव से निगेटिव होता है, बिकॉज यू मूव द चार्जेस। जो करंट फ्लो होता है मतलब आप चार्जेस को मूव करते हो, तो चार्जेस आप उसी डायरेक्शन में मूव करते हो जिस डायरेक्शन में आपने पोटेंशियल को अप्लाई किया है। सो देयरफॉर देयर इज अ लॉस इन द पोटेंशियल एनर्जी, इसलिए वो वहां पे पोटेंशियल ड्रॉप होता है थ्रू रेजिस्टेंस। ओके, लेकिन अगर वहां पे बैटरी आता है जो निगेटिव, पहला निगेटिव टर्मिनल है और बाद में पॉजिटिव टर्मिनल है, तो इन दिस केस व्हाट हैपेंस इज यू मूव अ चार्ज अगेंस्ट दिस एनर्जी, इसलिए वहां पे गेन होता है, इसलिए आप वो पॉजिटिव वी लिखते हो। सो इट इज ऑल कनेक्टेड। So what I'm explaining you here is the same what you have done in the previous subject, लेकिन उसको हम लोग अलग नजरिए से देख रहे हैं। वहाँ पे सिर्फ पोटेंशियल ड्रॉप और पोटेंशियल प्लस होता है, माइनस होता है, ऐसा बोलते हैं। यहाँ पे वही चीज मैं आपको वर्क डन के हिसाब से समझा के दूंगा। Am I clear? Are you getting this? सब लोग सो गए हैं?
No, miss.
No, ma'am.
Okay. So work done or the energy has to be spent. Okay, whenever you are moving a charge, either in the same direction of the electric field or against the electric field, and this is the in general formula. अगर आपको distance पता नहीं है, okay, and you just know the initial and ending point, then you need to integrate. Okay, so what we do is एक suppose ये total अगर मुझे आपको
मिस चार्ज दिया रहेगा ना उसमें, क्यों?
yes, everything will be given. So suppose आपने A to B move किया, okay, this is A and let's say this is B. So what you are doing, you are suppose आपको ये distance पता नहीं है, तो आप क्या कर रहे हो, इस लेंथ को ना छोटे छोटे पार्ट में डिवाइड कर रहे हो, and this distance is DL. This distance is DL. So अगर आप DL इतने डिस्टेंस में चार्ज को मूव करते हो, तो कुछ वर्क डन होगा, दैट विल बी से DW. ओके, फिर से DL से मूव किया और DW होगा, फिर से DL से मूव किया और DW होगा। ऐसे आप इंटीग्रेट करोगे फ्रॉम A to B, सो यू आर गोइंग टू गेट इनफाइनाइट नंबर ऑफ DW, स्मॉल वर्क डन। तो यहाँ पे हम लोग इंटीग्रेट कर रहे हैं, मतलब क्या कर रहे हैं, हम लोग वो स्मॉल वर्क डन को ऐड कर रहे हैं। whenever you are doing an integration, basically it is adding up. Okay, so I am adding all those DW. Suppose दूसरा वर्क डन है, यहाँ पे तो मुझे लिखने को नहीं, suppose with DL you get a small work done which is DW1. Okay, फिर से DL से मूव किया, you get DW2. Okay, so ऐसे आप स्मॉल लेंथ से अगर चार्ज को मूव करोगे तो आपको मिलेगा DW1, DW2, DW3 एंड सो ऑन टिल यू रीच टू B पॉइंट। ओके, सो ऐसे ये सब DW1, DW2 को अगर मैं ऐड करूंगी, इफ आई ऐड इट, देन आई एम गोइंग टू गेट द टोटल वर्क डन। ओके, सो बाय डूइंग अ इंटीग्रेशन, व्हाट आई एम डूइंग इज आई एम एडिंग अप all those small work done when you move a charge in a small distance of DL. ये फॉर्मूला का मतलब समझ में आ गया? ये फॉर्मूला का मतलब क्या है?
Means
Yes,
to
is it clear?
Yes, ma'am.
means to find the total distance of charge ना.
यस यस यू बेसिकली अगर आप पूरा फॉर्मूला लिखते हो ना, आप क्या कैलकुलेट कर रहे हो कि डीएल लेंथ में अगर मैं चार्ज को मूव करती हूँ तो कितना वर्क डन होता है, अ वेरी स्मॉल वर्क डन। फिर से डीएल में ए से शुरू किया, डीएल 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 छोटे छोटे लेंथ से अगर मैं चार्ज को मूव कर रही हूँ, सो डी डब्ल्यू 1 डी डब्ल्यू 2 इतने छोटे छोटे वर्क डन होंगे। एंड बाय डूइंग दिस इंटीग्रेशन आई एम एडिंग ऑल दोज वर्क डन in order to get the total work done which is W. Okay, in order to get the total work done, ये सब ऐड करूंगी ना तो मुझे मिलेगा total work done which is equal to, this is equal to W. That is what is this formula. Okay, अभी work done तो ठीक है, अभी इसके आगे का concept है this is very important. So the next concept is this. Can the slide be visible? Slide दिख रहा है क्या?
Yes, ma'am.
ओके सो ये कंसेप्ट क्या है, द पाथ इंडिपेंडेंस। मतलब आपको ए से बी में जाना है, बट एज यू कैन सी देयर आर डिफरेंट पाथ। एक पिंक कलर का है, एक वॉयलेट है, ग्रीन कलर का है। ओके सो यू गो फ्रॉम ए टू बी थ्रू एनी पाथ, द वर्क डन इज गोइंग टू बी कांस्टेंट। सो वर्क डन इज ऑलवेज इंडिपेंडेंट ऑफ पाथ। Okay, and that is what is nothing but your conservative field. Okay,
But
so-
ma'am, displacement is different for different path, right? So
Yes,
how
that
can
is what they are saying. That is what they are saying. A to B में आप कैसे भी जाओ, straight line से जाओ या zigzag motion से जाओ, and as long as your starting point and end point is same, work done is going to be same. Work done same होता है. Okay,
मिस एक मिनट
and
स्लाइड ऊपर कीजिए ना.
पहले वाला.
Yes, miss.
So you go from A to B through different paths. Okay, A to B जाओ या through a pink color path, or you go with a violet color path, or you go with a green color path. Okay, you take a longer turn or you take a shortcut. Work done in any closed circuit, as long as your starting point and ending point are same, work done is independent of path. Okay, then comes the important concept. हाँ बोलो.
But ma'am, in terms of single charge, if we take from point A to B, the paths are like different. So the displacement will be more for different, like for W1 is more displacement.
Yes, but
with
उसमें
compared to
क्या होता है ना, उसमें क्या होता है, somewhere you get a, sometimes you get a positive value, कभी आपको negative value आएगा, so addition करके ना वो work done same ही आता है। आप अब you can take any I mean any problem you can take and you can calculate the work done, you will get the same answer. मतलब आप straight line से जाओ या फिर आप circular motion से जाओ, वर्क डन का आंसर सेम ही आता है।
Okay, ma'am.
Recording stopped.